Okay, section 1.1, sets of numbers. We're talking about classifying numbers into the subsets to which they belong. We're looking at the worksheet here. The first set of information is to decide what these definitions actually are. So we can take a look at a PowerPoint slide here quickly just to get the definitions. When we look at the sets of numbers here, we're actually looking at all of the numbers that we're talking about right now being real numbers. That's the box that we're looking at around here. This whole thing is real numbers. So every single problem that we do, all the numbers are going to be real numbers until we get later in Algebra 2 when we start talking about imaginary numbers. Okay? So either real or imaginary. Within the real numbers, we have two different sets. About 2/3 of the numbers that we talk about are rational numbers, and about 1/3 are irrational. The rational numbers are numbers that can be written as decimal points or as fractions. The part that sets them aside from irrational numbers is that when you get that decimal version of the rational number, it either stops, like 0.5, or it repeats, like the 5.312, and then the line over the top says it goes 1, 2, 1, 2, 1, 2, 1, 2, and so on. So 1/3, which is 0.33333, would be a rational number. It's written as a fraction. That fraction continues and repeats. An irrational number, then, it is a number that does not repeat when you write it as its decimal form, and it doesn't stop either. So things like the pi symbol, the number pi, 3.14159, continuing and continuing, that's an irrational number. When I look at things like the square root of 2, the square root of 3, all of those numbers are irrational. If I'm looking at a number like, say, the square root of 4, the square root of 4 is actually a rational number. It's a square root, but it's not a square root in the sense that it has a root that continues on forever if I wrote it in its decimal form. If I do the square root of 4, I actually get 2. The square root of 4 is 2. That's a number that I can write as a fraction, 2/1, and it has a decimal that stops. But within those rational numbers, we have integers. Integers are numbers that are negative, positive, and 0. They include numbers that are not decimals, that are not fractions. And so it must look like what you would consider a whole number. And a full number, not any decimals. Whole numbers include 0 and all the positive counting numbers. So it's 0, 1, 2, 3, 4, 5, and so on. Natural numbers eliminate the 0 and are just 1, 2, 3, 4, 5, 6, 7, 8, and so on. There's symbols that go along with these. The rational numbers are represented by a Q, integers by a Z, whole numbers by a W, natural numbers by an N. Irrational numbers are just called irrational numbers, and we're talking all of them are part of the real number system, which is represented by a capital R. So now back to our sheet. If I look at the number -3, -3 is a real number because all the numbers that we're talking about are real numbers. It is also a rational number. It's a number that I can write like a fraction. It's an integer because it's a positive or negative. It doesn't have any decimal point and it's not a fraction, so that's an integer. And then I get to whole numbers. Whole numbers are 0 and 1, 2, 3. It doesn't have any negatives. It is not a whole number, so that's as far as I can go. Notice that these go in order, so once you have a stopping point, there's no need to continue. It's not a natural number, as you can see. The square root of 5. The square root of 5 is a real number. All the numbers we're talking about are real numbers. Then the question is it rational or irrational? Rational means if I did the square root of 5, I would end up with a decimal version that either stopped or repeated. So if I pull up a calculator and I do the square root of 5, maybe. Calculator's got some issues. But if you type it in your calculator and you have the square root of 5, you would end up looking at that decimal version that does not stop and does not repeat. Which then means that we're not looking at a rational number, which means it can't be an integer, can't be a whole number, can't be a natural number. It must just be an irrational number. And jumping down a little bit, negative 2.25, it's a real number. All the numbers we're looking at are real numbers. Rational numbers, can I write it as a fraction? Sure, that's 2 and 25 hundredths. So I could write it as a fraction with hundredths. I could write it, convert it to the mixed number version of that. I can do a bunch of different things, but I can eventually look at it as a fraction. Again, the hint to that is it's 0.25. The 0.25 stops. So that's a good place, a good thing to keep in mind. If it stops or repeats, it's a rational number. An integer are positives and negatives. It matches that, but it's numbers that do not have decimals or not fractions. So it is not an integer, and that's all we have.